Children at play. A girl spinning a humming top. A boy messing around with magnets and iron filings. Children's games can point to principles underlying the real world. Emily's top spins like the centers of the atoms of our body. The game of magnetic attraction that Andrew finds so intriguing rests on principles of physics which underlie some of the most advanced discoveries of medical science. Discoveries which have made all the difference to people with complex medical problems. People like, for example, Tracy Sinnott. She's 18 and to all appearances a normal, healthy girl, but her life has been shadowed by congenital heart disease. Richard Rogers lectures at a technical college in Southampton. He suffers from an illness which makes him subject to fits.
Okay.
Right, no problem.
When the fit started 5 years ago, Richard was very concerned that his teaching career was in danger. But he was in far greater peril than that. His very life was at stake.
But I'll talk to you about it in a minute. I'll just see this group and then I'll get back to you. I suggest you have a word with Dave when he comes back from holiday.
Yeah.
Doctors investigated him using the most advanced form of X-ray technology, CT scanning. Nothing was found to be wrong, so he was assumed to be epileptic. No one knew that he was suffering from a serious brain disease. Richard's only chance of survival depended on getting a more precise picture of what was going on inside his brain while there was still time to do something about it. The new technique of nuclear magnetic resonance scanning, NMR, might be the solution.
And you know anyway that there's a lot of money in the area, all right?
One of the scientists who pioneered the scanning technology was Professor Mallard.
Can I have half a pound of your best back bacon, please? Thank you.
As a boy, he'd watched the meat slicer in his father's grocery shop produce perfect cross-sections of an animal carcass. That memory was to inspire him when he became involved in research in this revolutionary technique.
Well, we had to cut it right up.
Professor Mallard's research team began work on an unusual machine in the 1970s. It drew on a standard technique for analyzing chemicals. That technique produced graphs which only an expert could interpret. Professor Mallard's aim was to produce not graphs, but recognizable images of the inside of the human body. If successful, doctors would be able to see any part of the body as if cut by a bacon slicer. After 3 years' work, the team at the Biomedical Physics Department of Aberdeen University had completed their prototype.
Well, here's hoping. Do you think we're all ready for our first patient?
Oh, I think so. It's as ready as it'll ever be.
At the University of Nottingham, Professor Peter Mansfield's team had already started work on similar lines. Professor Mansfield had broken the theoretical ground in 1973 and in 1976 produced the world's first live body image from NMR of a finger. He's seen here 2 years later working on a whole-body scanner, using himself as a guinea pig. Later models were to pay more serious attention to patient comfort. This machine has certain features in common with other NMR scanners. An electric coil, seen here around Professor Mansfield's chest, beams energy in the form of harmless radio waves through the patient. The coil also collects a returning beam.
Hold it, hold it.
It's placed close to the organ under investigation, in this case, the liver. Huge magnets make up the major part of the machine. The precise magnetic field they provide is vital for this technique.
Okay, fine. Now you need the nuts. Okay.
The Nottingham machine is ready for action. Its coil is connected to a source of radio waves. The coil will pump harmless pulses of energy into the atoms of the liver. These atoms send back a different pulse, which computers can turn into a picture of the liver. The radio pulse, and the atoms reply. Then another. Many recordings were taken.
Well,
Now, so what we'd like you to do is to sit up here on this couch.
Aberdeen's first patient came soon afterwards. He was a volunteer from the University Hospital. In this reconstruction, he's played by an actor.
And then hoist yourself up on there. Right.
Knowing that he was terminally ill, the patient volunteered to take part. The new technology came too late to be of any benefit to him, so he participated to benefit others.
You can see how it's made up of those magnets, the 4 black rings that you see, and then in the center there's the imaging tube that you're going to lie in.
Oh, yes.
Right, we're going to put you onto
It was known that he had cancer of the liver. The Aberdeen researchers were keen to see if tumours would show up on the NMR scanner.
I'll take you.
Quite a feat, Doctor.
There we go.
They also wanted to see how their scanner would work. Its 4-coil design was different from other machines, and its method of producing pictures did not rely on computer reconstruction like the Nottingham scanner, but on an ingenious process called spin warp.
The imager right
The volunteer who so patiently took part in the machine's test run was helping to make medical history.
Now, if you just remember to lie nice and still while we make your pictures.
Yes, sir.
This is looking from the...
In 1978, the years of hope and doubt were over. Professor Mansfield's team obtained these NMR pictures of a liver constructed by computer from their body scanner recordings. NMR imaging was a reality. The theory behind these pictures can only be fully understood by an expert, but Emily's spinning top gives a guide. Radio pulses force extra energy into spinning hydrogen atoms, found in all living tissue. The energy is then emitted like the hum from a top. When this takes place in a magnetic field, the emitted signals reveal where the atoms are and what kind of tissue they're in. Enough information to generate a realistic image.
Yes. I wonder if we can see the tumour in his...
Just like these NMR pictures, the legacy left by Aberdeen's first patient.
Ah, there it is. Yes, see it.
They amazed Dr. Frank Smith and Dr. Jim Hutchinson when they first saw them 9 years ago. They showed liver tumours far more clearly than expected.
Oh, yes. You can see very clearly that he has lots of tumours in the liver, here and here and here.
Aberdeen's spin warp technique for generating the NMR pictures was clearly a success. It's still used in commercial machines today.
Now there's a very large one with...
And NMR was revealed as a vital new tool for medical diagnosis. It could distinguish clearly between different types of tissue and provide easy-to-read pictures. No other technique could achieve the same results.
Can you go down another one?
Yes.
The research at Aberdeen and Nottingham was what finally saved Richard Rogers. Within a few years of their successful prototypes, the first commercial machines were installed in a few British hospitals, like the National Heart and Chest Hospital in London. Richard's consultant, still not convinced that he was an epileptic, sent him for a checkup. Wearing a head coil, a harmless device to focus radio waves on his brain, he had his first NMR scan. The scan revealed that he was not epileptic, as had been supposed. It clearly showed up the inflammation of the brain that was the reason for his fits, which X-ray and CT scans had not been able to show. Had this not come to light, the disease might have developed beyond the point of cure. Richard now comes to London for regular monitoring. He's been taking a course of steroids to combat this inflammation. The drug can have harmful side effects, so it's important for the doctors to monitor how the brain is responding. If necessary, the dose can be adjusted. The NMR images provide the information his doctor needs. The brain can be looked at slice by slice to check for any signs of damage.
I think you reduced him last time.
Good, well that looks all quite normal, doesn't it? If we just turn preview off, we can go up to the area where the problem is.
This machine can offer up a selection of slices so that any area which merits closer inspection can be singled out.
here, which looks quite clear, and there, and then down here in the occipital lobe. So that's all good news.
Doctors at the National Heart and Chest Hospital have become expert in interpreting the images from this new machine. They can spot minute differences in brain tissue.
This is last scan as far as I know.
Richard has been in the machine for over an hour. During that time, the machine has taken thousands of readings. Over 200 can be required to make one picture. These are put together like multiple exposures.
The head going down through the brain here.
This time, it's very good news for Richard. All signs of the inflammation have now gone. This means that the potentially harmful steroids can be reduced or even stopped. Such close monitoring would not have been possible without NMR. Richard will be back just to make sure. If next time it's found that there are still no traces of inflammation, then Richard will have been cured.
Lines in here, that's perfectly normal. Those are the foldings in of the brain. So this is perfectly normal.
For Tracy, this is a worrying time. When she was 3 years old, she had a hole-in-the-heart operation in which a substitute valve was placed in one ventricle. Recently, the valve has begun to leak. Her doctors are worried about the extent of the leak, but as yet they have no precise information.
Until the knocking sound finishes, then it does help the picture. And even if you just move half an inch, it puts the measurements out. Okay.
NMR can provide precise information, so Tracy has been sent from the Midlands to the National Heart and Chest Hospital to be examined on the NMR scanner.
If you'd like to have a seat there, okay? This is where you're going to go.
Today is her first visit. Tracy is asked to put on a body coil which will focus the machine on her heart and chest, the area to be imaged. It's a nervous time for her mother as well as for Tracy.
Sort of on your tummy while I put you in, because you're quite nice and small, but it's just a bit of a tight fit sometimes, okay?
Doctors and scientists here have been developing both medical skills and imaging techniques to exploit NMR to the full. They're particularly interested in looking at the heart and circulatory system. Tracy is just one of over 1,000 people whose heart has been monitored here. Tracy will need to stay in the machine for almost 2 hours. But NMR is a safe technology. The only adverse effect she'll suffer is boredom. Within 10 minutes, the first pictures are ready. Slices can be obtained at any angle through Tracy's body.
Yeah, but I don't want to go that far, so I'm putting it in far before.
Here, a slice through Tracy's chest as if the top of her body had been sawn off. Because the heart is moving, each recording for the picture must be taken at the same point during the beat. Mr. Donald Longmore, who heads the NMR unit, was once a heart surgeon, but when he realized what NMR could do, he gave up surgery and devoted himself to this technique, which can warn of disease long before surgery is required.
Without changing files, but you can't.
Well, we're really off the bottom of it, I think, Philip. That's why you can't see the septum.
It is these sequences of Tracy's beating heart that give NMR such an advantage over other techniques. The machine takes individual still pictures at different points in the heart's beat and then runs them together, creating the illusion of motion. It's an eye into the heart that has no equal.
In there patiently for all that time. You've produced some lovely pictures and a lot of information about the problem you've had. You've had a jolly good operation there. Well, these are thin slices through you, and your head's out, sticking out there, and your feet are sticking out this way.
From the detailed moving and still pictures, Mr. Longmore has discovered that the leak is not as serious as feared. Tracy will not need to be scanned again for another year. In the meantime, life goes on for her as normal. With these images, doctors can check heart rhythm and even see the blood flowing through it. Mr. Longmore is already scanning the hearts of healthy patients in a long-term survey into heart disease. He hopes that one day, mobile NMR scanners will be available to monitor the nation's health. The breakthrough in NMR came about not simply by theoretical pioneer work in British universities, but in the creation of commercial technology by engineers and designers at Oxford Magnet Technology. The key to NMR technology is the ability to create very powerful and accurate magnets. Magnets which use superconductors cooled by liquid helium. The next generation of machines is already on the drawing board. The search is on for even higher magnetic fields which can be varied as required.
Take the bends the other way around.
Take the elbow that way, and then all this will come out this way, and the elbow that way, which will then be the service end.
That's right. That's
So
fine.
that way,
Yeah, let's look at that.
The magnets are then combined into a total system which is painstakingly built around them and includes sophisticated computers. This is done by medical manufacturing companies. A world leader in the field is Picker International in London. Each machine goes through weeks of rigorous testing. Over 30 test scans are conducted, for which they use a human phantom, a cylinder of water and chemicals which stands in for the human body. It will sound out every part of the system. Together with the main parts of the machine, the computer systems and the powerful magnets, come a range of coils, like those worn by Tracy and Richard. An eye mask which allows detection of tiny spots on the eye, a telltale sign of brain tumours. The ear coil can reveal small growths on the acoustic nerve, which could produce ringing in the ears and subsequent deafness. The neck brace can show cysts developing on the spinal cord, which other scanners might miss. And a knee pad which can reveal cartilage injury. But the possibilities of NMR do not end with imaging. At the Royal College of Surgeons in London, they're using a different NMR technique, spectroscopy, in experiments on transplant organs that may eventually save human lives. This rat's liver could fail when transplanted if it's been stored for too long. It's a problem which affects human transplant organs. The question is, can you check in advance that the organ won't fail? NMR spectroscopy provides an answer. The liver is placed in a small NMR machine. The machine's output is not pictures, but a series of spectra, peaks and troughs which reveal the presence of chemicals essential to the effective working life of the liver. The first set of readings shows the liver to be in a healthy state. The researchers are trying to extend storage time. The liver under test has been specially treated. It now goes into cold storage for 24 hours, twice the normal time a liver for transplanting can be kept. Next day, the stored liver is put back in the NMR machine. Checks show that it could be transplanted. Such experiments may one day give doctors that vital extra time to save human life. Research of a more fundamental nature into the application of NMR is taking place at Nottingham University. In common with other groups around the world, they're trying to build an NMR microscope. If they succeed, man will be able to watch the processes going on inside a living cell. Electron and vacuum microscopes are among the most valued tools of science. But they only enable one to see objects that are dead, because they must first be stained or coated with metallic film. These microscopes can magnify many thousands of times, but cannot see the processes of life. Sooner than anyone had dared hope, the Nottingham team gained an important success. They became the first group in the world to obtain NMR pictures of a living cell, just months into the start of their research. A geranium stem is carefully placed in the access port of Nottingham's NMR microscope. It takes 1 minute to create an image. It's based on measurements of hydrogen atoms, an essential constituent of water and of all animal and plant life. For Professor Peter Mansfield, head of Nottingham's NMR research unit, this is another major advance.
What do you think these small spots and bright dots there, what are they then?
I think we're just beginning to pick out single cells within the...
A single living plant cell, just 0.08 of a millimetre across, is seen on the screen for the first time.
70 to 80 microns, I should think.
And what about flow?
The team are confident of seeing cells only 0.04 of a millimetre in size. This could lead to a revolution in human biochemistry. If living human cells can be examined, we may at last be able to understand the process of disease. The pioneering work of Professor Mansfield has produced another world first, an NMR body scanner which takes snapshots. It dispenses with the need for many recordings over several minutes. One is enough.
And optimize the imaging parameters. And in real time,
a group of doctors evaluate some of the first images from patients using this latest advance called echo-planar imaging.
What the heart looks like despite its beating. You can show it despite it beating irregularly because you're doing a snapshot, and you can actually show flow through the heart, whether it's normal or abnormal, all in one.
And also, I think
patients with irregular heart rhythms can be monitored. With other NMR systems, only regular heart motion will produce clear pictures. Irregular beats will blur the images.
The problem with this young lady is that we think she may have multiple sclerosis, but with our present MR...
The echo-planar device dramatically shortens the search for evidence of multiple sclerosis, in this, the brain of a young girl.
Could we ask your help with your ability...
Because pictures are obtained straight away, doctors can instantly focus in on any area which seems to contain the lesions caused by MS. Signs of this terrible disease are unfortunately only too clear.
See our variations in these lesions here, this one and that one over here. Yes. Echoplanar imaging is particularly...
Another search for cysts in the liver. It's difficult to obtain the sharpness required with conventional NMR because the liver is often in motion. Professor Mansfield's new scanner can easily cope with this.
Point out here that one advantage of echoplanar imaging over, for example,
and it can even handle the digestive system. Normally, images from the abdomen are obtained with a barium meal and X-rays. With echoplanar scanning, all it takes is a good drink of water.
Much more easily. And also, we are able to...
This research from British Petroleum is designed to improve techniques for extracting oil from the seabed. Water is pumped through oil-bearing rocks to force the oil out, but nobody knows what precisely is happening. Now the echoplanar NMR is able to follow the movements of the water and oil. The Nottingham University project could lead to more effective oil extraction. But perhaps pregnant mothers and their unborn children stand to benefit most from Professor Mansfield's breakthrough. Because pictures can be obtained in only 1/64,000th of a second, echoplanar imaging can freeze the motion of the fetus. This machine, the first in the world, provides the only safe way of looking at blood flows in the womb, which can be of vital importance in pregnancy. Images of the unborn child are far more distinct than those obtained by the more usual ultrasound technique.
And here is the fetus itself, and this is the spinal canal in the fetus. And if we look at another plane, perhaps we can follow that through.
The unborn child's spinal canal is checked and found to be sound. This marriage of physics and medicine has provided a safe and vital screening for the beginnings of life. Much of the credit for recent advances in NMR must go to Professor Mansfield, who's already planning the next leg of its development. However complex NMR has become, its beginnings go right back to first principles. the ability to cross-section human organs is becoming a commonplace of medical practice. More is being revealed of the hidden man.